All right, good morning. Today we're doing the very last section in the chapter. Test next Tuesday, and then spring break the week after next. So today we're just doing more proportions, but I think these proportions are a lot easier to see. Do you guys remember when we had those triangles yesterday, and we had like 4 and 3 and x and like 12 or something, and you had to draw the triangles separate from each other? Today's is going to be easier. But I do want you to notice that there's a number on the bottom here. You guys see how there's numbers on the bottom of the triangles? Okay, so it's going to look a little different today. So we're going to talk about proportions in triangles. This is the side splitter theorem. Did you guys ever watch SpongeBob?
Yeah.
Do you know the F is for friends that do stuff together?
Yes.
U is for you and me. Okay, so I tried to make my fun triangle, and then I just put SB in the middle for SpongeBob. Anyway, I was trying to make something up. So a side splitter theorem just means that there's only going to be numbers on the sides, not on the bottom of the triangle. If the numbers are on the bottom, you still have to redraw the triangles separate from each other. But if there's numbers on the side, like 4, 3, x, 6, or whatever, it's a side splitter theorem where you can just do a proportion, 4 over x, 3 over 6, cross multiply and solve. So it's a lot easier to see, I feel like. So that's the side splitter theorem. So let's practice. How do you think I could set up this proportion?
10 over 8.
10 over 8, 5 over x. Do you guys see that proportion?
Yeah.
You could also do it left to right. If you go left to right, just go left to right again. You could do 10 over 5, 8 over x. Notice you're still multiplying the 8 and 5 and the 10 and x. Do you guys see that? So just do it the same both times. So yeah, 10 times x is 10x, 8 times 5 is 40, divide by 10, 4. I like the side splitter theorem. How could I set up this one?
X plus 4 over 9, 2x plus.
Okay, so you're going left to right,
Yeah.
over 9, and then
2x plus over 12.
so that's left to right, but you guys know you could do x plus 4 over 2x, 9 over 12. You could do it
12x
that way
plus
too.
48 over equals.
So 12 times x is 12x. Do distributive property. 12 times 4, 48. 9 times 2x. So minus 12x. 48 equals 6x. What's 48 divided by 6?
8.
Yes. Okay. Okay. Next one. I like to just do the proportions like this because I feel like I can just see it. And then cross multiply. Do you guys see that?
Mm-hmm.
So x over 6, x plus 1 over 9. 9 times x is 9x. 6 times x is 6x. 6 times 1 is 6. Don't forget distributive property. Minus 6x. 3x equals 6. What would x be? You guys awake? 2. Emma, welcome. I missed you. All right. Are you okay with the side splitter? Side splitter, not so bad. Next, we have proportional parts of parallel lines. So I have a son named Jake, so I just put J-A-K-E, but I also have Jake right here. So there we go. So same thing. We've just got parallel lines. But you could do J over A, K over E. You guys see that? You could even go left, right again. However you see it. So let's try this one. How could I set up this proportion? 12 over 5. X over 6. Cross multiply and solve. 5x equals, what, 6 times 12? 72?
Yeah.
And I don't know what 5 divided by 72 is. It would be a decimal, though. I do know that.
I think it's like 0.1.
What is 72 divided by 5?
Like 14.
14.4. 14.4, yeah, good. 14 point something. Okay, so this one, how could I set up that proportion? 4 over x, 6 over 5, 4 times 5 is 20. 6 times x, 6x. You'd get another decimal there.
3.33.
8.3333?
No, 3.33.
What is it?
3.
Oh. Okay. Yeah, see, I'm getting older. I can't see, I can't hear. Okay. Last but not least is the triangle angle bisector theorem. So I did fat cat. Fat cat. All right, so again, same thing. You could do FA over CA, so this side over this side equals this side over this side. That'd be left to right, but you could also go top to bottom. This over this equals this over this. Okay, so like, how do you see this proportion?
X over 13.
That's how I see it. I could just put the line. That's how I see it. But you could also go left to right, either way. So x over 13, 9 over 10, cross multiply, and solve. I don't have a calculator, so I don't know 9 times 13.
107.
107?
I got one today.
117, 107.
Oh, 117.
Yeah.
Divide by 10. 11.7. Okay, how do you see, do you guys see it like this?
Yeah.
8 over 10, 10 over x. So 10 times 10 is 100, 8 times x is 8x, and then 100 divided by 8.
12.5.
12.5. Thank you. Again, I see this one like that.
Yeah.
X over 16, 7 over 6, cross multiply, 7 times 16, 112, 6 times x. What is 112 divided by 6?
18.6 repeating.
18, I'll say 18.7. Because I don't like to, is that what it is or no? Or what'd you get?
I got the 18.66.
Yeah. Yeah. I just don't like to write 666. All right. Okay, there's a couple more challenging problems, something to think about, and this will be on your test. I've looked at the test. This will be on the test. So, when I want to do this proportion right here, I would do 6 over x and then 4 over something. I need to figure out what this piece right here is. Well, if the whole thing is 6 and this is x, what if this was 2? What would this piece be?
X minus 2.
So you're subtracting 6 minus 2. Does that make sense? So since I don't know that it's 2, it would be 6 minus x. Does that make sense?
Yes.
So then you would set up the proportion 6 over x, 4 over 6 minus x. So 4 times x is 4x. 6 times 6 is 36. 6 times negative x would be negative 6x. Be careful there. Plus the 6x on both sides. So 10x equals 36. 3.6. So if the whole thing is 24 and that piece is x, what would that be? 24 minus x. Good. So then I can ignore that. So 8 over x, 12 over 24 minus x. I need your help. What's 8 times 24? Don't do it in your head.
192.
Thanks. 192 minus 8x, because I got to distribute. Plus 8x. So 20x equals 192, and then I need your help again.
9.8.
9.8?
It's 192.
What is it?
9.6.
9.6.
I think.
196.
Yeah.
All right. How do you feel about these proportions? Are they easier?
Yeah.
No. Yeah.
No. I think you could see them better. You will have a few problems where you've got 2 separate triangles just like we've been doing. So, like x on this triangle would correspond to what on the other? 5. Do you guys see that? So x over 5, and then 12 corresponds with 8, and then you cross multiply. So what about this one? 21 would correspond with x, and then 9 and 6. And then you cross multiply. Do you guys remember you can reduce it if you want before you cross multiply to make the math easier, but you don't have to. Are there any questions? I kind of went through that super fast. Thank you. Okay. I just thought this was cute. We're so similar. Okay. Your assignment, is it? It's not unlocked yet. Let me unlock it really quick and we'll look at some problems.
7 students, please pardon this interruption. If you are testing today and your path says that you are to go to room 231, change that room number, you'll be in 113. So that's just if you receive a path test, or if you have already received that, and says room 231, we'll be testing in room 113.
Wait, when am I supposed to do this?
Alright, if you refresh, it should be unlocked now.
I thought the comment was cute.
I don't know.
It is kind of cute, isn't it? Why are circles so hot? Because they're 360 degrees. And then he's...
Why does the triangle cute?
Okay, so you're just setting up proportions. How do you see number 1? 3 over 1, x over 1.5, or 3 over x, 1 over 1.5. Either way. So you go top to bottom, left to right. So 1 times x is 1x. What's 3 times 1.5?
4.5.
And that would be your answer. Okay, so most of them, you're just setting up the proportions. Let's look. Go to number 8.
Oh gosh.
Number 8, you have to find x and y. So when you go to find x, just ignore this one. How would you set up that proportion?
36 over x.
36 over x, 20 over 21. Cross multiply and so on. When you find y, just ignore the x. So how could you set up the y proportion?
36 over
36 over y.
20 over.
Yes. And then cross multiply and solve. So it's just 2 separate proportions that you have.
Wait, are they? What is this for?
36.
Does it say after first hour? I think you guys are getting surprise drug tested.
Really?
Oh, I'm not gonna be. Let's go.
Go to number
Wait.
20. Oh, you want me to wait?
I'm not gonna be here. Let's go.
So number 20 are those that are a little bit harder. So this, I could do 20 over 8, but then I have to figure out what this part right here is. So if the whole thing is 35 and that piece is x, what would that piece be?
35 minus.
Yes, 35 minus x. So you would do 20 over 8, 35 minus x over x. And again, you can reduce that if you want to make the math easier, if you want. Look at 23 real quick, because I always have students mix this one up. So on 23, I would do 3 over 12 and then 4 over something. Notice the entire length is x. That I always have people do 4 minus x, but it's not 4 minus x on this one. It's x minus 4. because the whole thing is x this time. X minus 4. So you do 3 over 12, 4 over x minus 4. So it's always the big piece minus the littler piece. Big minus little. All right, all proportions. Tomorrow we're doing big ideas math over this stuff. And Monday review, Tuesday test, Wednesday, Thursday, Friday Pythagorean theorem.
No.
Poggers.
Record. Both.